I kind of got into this rabbit hole of philosophy a few years ago. I had a friend named Mike. He was getting his master's in philosophy, and he was challenging me to read these more complex things that he was going through. And he'd use words like metaphysics, and I would nod and smile. And then as soon as he would leave, I would go to Wikipedia, and I would try and figure out what in the world he was talking about. I'm still not 100% sure I know what metaphysics really is, but I think I have a better grasp of that now. So after that, I went and bought a book of Aristotle's works, and I did what anybody would do. I put it on my bookshelf for about a year before I picked it up. But eventually, I picked it up and started reading it, and as I stumbled through the complex sentence structures and the really odd wording as it was translated from Greek into English, I started to see these deep connections between what Aristotle was talking and writing about thousands of years ago and what I do every day as a software developer. Aristotle was taking these large, really complex ideas that he would observe in the world around him, and he was breaking them down into these small, fundamental, provable bites that he could explain to everyone around him. And then he would take an object that he was observing, and they would see the abstract qualities of the object, and he would remove those qualities from the object and prove that those qualities exist apart from the object itself. And, well, it was a really long and complicated rabbit hole. But one thing that kept resurfacing throughout all of his works was this idea of craftsmanship, the idea that an object that's created is a direct reflection of the creator of the object, that the craftsman's patience, perseverance, and ingenuity are directly seen in what they create. Now, oftentimes, it's really easy to tell the difference between something that's created by a novice or something that's created by someone with a little more experience. But it's a little harder when you look at something that's created by something that's created by someone with a little bit more experience and something created by a master craftsman. Often you have to look really closely at the details to see maybe how the joints fit together in a piece of furniture, or you look at the sustained quality over time and see, this was built 50 years ago and it still works just like the day it was built. Aristotle had some thoughts on what it takes to become a master craftsman. He said, "This is why we regard the master craftsman in any field as more deserving of respect, more knowledgeable, and wiser than manual workers, because they know the causes of things being done." See, he said, a master craftsman is not satisfied with just knowing that something works, but they seek to know why it works. Now, the idea of software craftsmanship isn't a new idea. There have been plenty of books written about the subject. There's even an ironic manifesto website that you can go and sign that's not very highly made, which is the ironic piece. But reading those books and signing that manifesto aren't bad things in and of themselves, but I think that they miss Aristotle's more simple idea of what a master craftsman really is. Let's look at a couple of master craftsmen and see what we see there. So Dieter Rams was a designer at Braun, the product company based in Germany, for over 50 years. He's made a number of iconic products that are easily recognizable, and he's known for his clean, simple design aesthetic. But he didn't just create these iconic products that are very clean and simple looking just for the sake of their appearance, but he had the goal of creating sustainable products. He wanted to create things of high quality that had a timeless styling to them, so that they wouldn't just read to reckless consumerism where people would keep constantly upgrading. He wanted to create things that would last for a long time. So he ended up making design decisions that supported his belief that what we're building should be of high quality. It should be created as if a master craftsman was building it. Another example is John Skeet. John Skeet is the #1 ranked user on the programming question and answer website Stack Overflow. As you can see, well, it's cut off a little bit, but John Skeet has answered 30,000 questions on this programming website. He's far and away the #1 user. The second place is like 75% of where he is. But if you look at the questions that he's answered, he doesn't give quick answers. Almost always, his answers involve an explanation of why things are happening the way they are. John Skeet just has a deeper fundamental understanding of what he's talking about. One of the questions that he answered was about what a user thought was a bug and how dates were handled in Java. John Skeet answered and says, well, it's not a bug, and if we actually go and look at the history books, in 1927 in Shanghai, they rolled the clocks back 5 minutes and 52 seconds for whatever reason. But John didn't even stop there. He went and updated his answer 5 more times as Java as the Java language was updated, and then later saw that the time was changed from 5 minutes and 52 seconds to 5 minutes and 58 seconds where the clocks are rolled back. Now, you may be thinking, okay, yeah, these people are really well known and they're great at what they do, but how do we move down the path to becoming a master craftsman in what we do? Well, I think it all starts with curiosity. I think it starts with asking a lot more questions than we ask right now. By asking more questions and specifically asking why things are happening the way they are, we move away from just following trends in fashion and design, and we move away from copying and pasting code that we see on Stack Overflow to looking for the deeper answer, to figuring out why things function the way they can so that we have a truer understanding of the world that the problem we're trying to solve exists in. If we're asking questions simply to find facts, though, we're still missing out on letting the question change who we are. If we look back at the example with John Skeet, we see that John looked outside of software development itself to find the answer to the problem he was looking at. He looked and saw that you have to actually look in the history books to see that time is sometimes changed, and that our simple mental model that time is this linear thing that just is the way it is isn't true because of the entrance of switching between calendars and the introduction of time zones and things like that make it very hard to actually look at times historically. So with a deeper understanding of that's how times and time zones have changed things, we understand that in order to build a system that truly can handle times and dates accurately historically, we have to create a very flexible system that can allow changes to be applied later on. And as John did, we have to a lot of times look beyond where we expect to find the answer for something. We need to look just beyond what we do on a daily basis in software development. Aristotle noted something similar to that when he said, take the relation between medicine and geometry. The doctor knows that circular wounds heal more slowly, but is the geometrician, I think, who knows why. Or a more concrete example is, let's say we're starting a new software project and we need to pick which language we're going to write it in. We could go and look for charts and graphs that show the difference in performance between the languages we're looking at. And while that may give us an answer immediately, we're depriving ourselves of learning how to actually benchmark software for performance. That's far more valuable than any facts you're going to learn from some website. And if you think about the old adage of, if you give a man a fish, he eats for a day. If you teach a man to fish, he eats for a lifetime. In order to become a master fisherman, we first have to learn how to fish. We can't just take fish from other people. The knowledge of how to do something is always going to be more powerful than simply the facts. So, kind of to illustrate this, I'm going to use a hobby of mine. So, I like to build things in my garage, so I have a lot of tools. And let's say I want to create an inventory system for all the tools that I have so that I can answer questions like, do I have the necessary equipment to perform this task or build this thing? Or I want to answer the question of, do I have enough of this thing that's something that I use up and that I'll be able to know if I need to order more of it or go to Lowe's, do whatever. So if we think about that a little more, we start to think, okay, we're asking questions like, all right, we have more than just like one type of tool. We have screwdrivers, we have drills, we have saws, we have hammers, we have wrenches. We have all these different types of tools, and so they can be classified separately inside of our system. When we think about it the next level down, we could have 20 different types of screwdrivers that all have a very, very specific purpose that you may use once or twice, but if you don't have that tool, that once or twice that you need it for a specific purpose, you're not going to be able to do that thing. And then if we think about the different tools even more is, some tools require specific parts in order to operate. Like a drill, you have to have a bit to put in the drill, otherwise the drill is worthless. Or with a saw, you have to have a blade to put in the saw, or else the saw's not going to work. You won't be able to cut anything. So then we think about, well, now we're beginning to gain an understanding of the tools themselves and the environment in which they're operating. We get a clear picture of what we're actually trying to build and a deeper understanding of how that affects what we're building. So we'll draw conclusions like, that bit is what is necessary in order to drill a hole that's, say, 3/4 of an inch wide. What drill we use doesn't matter, but what bit we use is the key thing in that situation. Or if we step back even further, we ask the questions like, why does the client even need us to build this? What's the real question that they need an answer to? What's the problem they need solved? We need to ask these questions, otherwise we're going to be building something that isn't necessarily needed. Just as a philosopher trying to explain the meaning of life without having any actual life experience, we need to try and gain experience in the domain where we're trying to solve problems. And once we've gained this understanding, then we can kind of move on to start to analyze what we've learned. When we begin this analysis, we start to see relationships forming between these disparate facts and answers that we've gathered along the way. In Aristotle's vast observations of the world around him, he said, "There will be several patterns and thus several forms for the same thing. In the case of man, there will be the form of animal and the form of biped, as well as the form of man himself." Now, Aristotle was actually widely regarded for his advances in the field of biology. He spent a lot of time observing animals and plants around him and drew a lot of conclusions. He saw these patterns and abstractions in what he saw, and he realized that man has a lot of similarities with animals, and so man must be an animal and can be classified thusly. And they also saw that a lot of animals use two of their limbs to walk around, and they can be classified as bipeds, as he was explaining. When we look at this, we look at what we've learned as more than just a collection of facts. We start to see connections and patterns emerge in what we've learned. For example, in our workshop, we can have different types of drill bits. We can see that we have a spade bit on the left and then a hole saw on the right. Both of these are used for drilling a larger hole in a material, and they basically do the same thing, so they're almost interchangeable in the purpose that they serve. Now, so if we look back, we have tools, and then we realize that those tools, or some tools, require these parts, but these parts don't just belong to a single tool. These parts are interchangeable. You can use different bits inside of the same drill, and so these bits and blades and things, they have to be classified separately from the tools themselves. And then if we look at the tools, we can see there's any number of tools that all can perform the same kinds of tasks. Like you have different types of saws, and they all cut things, and you have different types of drills, and they can drill a specific type of hole, or they can add precision in the task that you're trying to complete. But then when we really look at it, we think, what is a drill really doing? A drill is really just cutting a circular hole in a piece of material. Well, that can also be performed by a router with a plunge bit, where the router just pushes down into the wood, and then you can make something that's not just a hole in the wood, but you can make a square or any kind of shape as long as you have a template that you can run the router with. Or if you have to make a very precise hole to a very precise depth, you can use something like a drill press here, which has a depth gauge and a table that'll hold your material. And once we've learned all this about the knowledge that we've learned, and we've made all these connections, everything that we've learned is really useless if we aren't able to communicate it with those that we work with. Now, the philosopher's audience was oftentimes whoever was standing around listening to them, or whoever ends up reading their works thousands of years later. But for us in the software development industry, our audience is often our coworkers or our client, or even the computers that run the software that we create. We need to come up with a common language so that we can talk about these complex ideas and communicate them clearly between ourselves. How many times have you been in a meeting and someone says, "Oh, you mean a blank? Is it a card, or is it a block? Is it a page, or is it a view?" Now, these may seem like minor and irrelevant differences in the wording that we choose, but by spending the time to analyze what we know and come up with this common language, we're able to create a more unified system that is unified not only in the user's experience and the interface that the user interacts with. We can also use the same wording down into our code so that when we talk about something in a meeting, we're all using the exact same language and that we don't have any kind of barrier of communication. So in our example of the workshop, you have different types of tools, and we can give more formal names to categories of tools. Like you have hand tools and power tools and stationary shop tools that are the big things that you kind of have to wheel around. And then you also have interchangeable parts. We want to make sure we make that distinction so that everyone knows what we're talking about when we're talking about these parts. And then a couple of those parts could be bits and blades like we talked about. Once we've dug through all the questions and gained all this knowledge in the domain that we're trying to solve a problem in, and then we analyze what we've learned, we get to a point where we can start eliminating the unnecessary things and hiding complexities so that we can create a simple product that's easy to use. Now, the appearance of something being simple or not is largely based on how it's described. If you describe something as simple, it's going to be viewed as simple. Whether that description is an API in your code, or the visual user interface that a user sees, or just how you talk about the product to your users and clients. And this complexity can be both internal, when we're talking about APIs and things like that, or it can be external, as in the marketing and the user interface. Aristotle sought to make everything that every theory that he created as simple as possible. He said this about simplicity: the most accurate sciences are those that are most concerned with first principles, since those that are derived from fewer principles are more accurate than those that have additional ones. When we introduce dependencies into our products that we're creating, whether it's internal dependencies in our code or it's dependencies of the user having prior knowledge in order to interact with our product, we're creating risk. We're making it so that it's less likely that we'll be able to accurately predict how the user will interact with our product. By moving away from that basic implementation, we're moving the target further and further away from the user and introducing unpredictability and therefore risk. Now, this is a foundational principle in computer science. Brian Kernighan, one of the creators of the C programming language back in the 70s, I think, said that controlling complexity is the essence of computer programming. And Edgar Dijkstra said, the computing scientist's main challenge is not to get confused by the complexities of his own making. We need to be able to take all this complex structure that we've developed in this model that we have of the world where our product will live and be able to hide it internally inside of our product and not expose it when it shouldn't be exposed. So in the example of our tool inventory system, we have drills that are very closely tied to the use of bits, and we have saws that are very closely tied to the use of the blades of them. But what we want to do is we want to take all this information we know about drills and all this information we know about the bits that go along with them and boil it down to as simple of an interface as we can, where the drill really only needs to know, will the shank size, which the shank is the part of the drill of the bit that you stick into the drill, and the chuck is the part of the drill that receives the bit, do those fit together? That's really the only thing that matters. They shouldn't know about anything else about each other in our system. By doing that, we're introducing more complexity and therefore more risk in our project. And this risk isn't just internal to what we're building. If we're coupling our project or product to prior knowledge, the user's not going to be able to interact with it in a predictable way. We're minimizing the number of users that can effectively use our product if we're requiring them to know things coming in. In order to achieve true simplicity with the products that we're building, we need to determine who our product is for and also what features are absolutely necessary in the process or in the product. Aristotle described the process of eliminating these things by saying, every art does its job well in this way, by looking to the mean and leading its products toward it, which is why people say of things well done that you cannot add anything or take anything away, since well done is ruined by excess and deficiency and achieved by the mean, and good craftsmen, as we were saying, work with their eye on the mean. If we look back at Dieter Rams that we talked about earlier, he wanted to create sustainable products, and in order to do that, he used his simple styling and his a minimal interface to most things. Well, he described design as good design is as little design as possible. Less is more because it concentrates on the essential aspects and the products are not burdened with non-essentials. Back to purity, back to simplicity. Our pursuit of taking the knowledge that we've learned and creating a truly simple product with that knowledge should permeate every decision that we make in our creative process. Every decision that we make is really about just balancing risk on whether it's adding that third-party library to our software that could possibly introduce a bug, or whether it's saying things like, well, everybody knows how to do that, when in reality, not everyone does know how to do that. Or maybe it's just adding that really cool but really unnecessary feature to our product. We have to be able to choose wisely in what we're going to allow our project to depend on. Aristotle thought that this wisdom in being able to make these tough decisions is what marks a master. In talking about arts and crafts, we apply the term wisdom as meaning technical mastery to those who are most accomplished in their special skill. If we look once again at this workshop, let's say as we said earlier, we have this idea that we want to be able to complete this one specific task, and we want to know, yes or no, can I complete it with the equipment that I have available? What we need to be doing is only collecting the absolutely required information, such as what does the user want to do? Do they want to cut a hole? Do they want to drill a hole? Or do they want to nail or screw something together? And then we take any other details that are absolutely relevant, and then we output the answer to them. We don't need to be introducing extraneous things that will simply confuse the user or cause them to be distracted. Similarly, if the user's just trying to say, hey, do I need to purchase more of this thing that we're tracking in the inventory, we only need to display the information that says, this is what it is, and these are the things you need to order more of. If we're displaying other things, we're introducing risk that the user is going to get lost or distracted or confused by everything else that's going on. So this idea of craftsmanship is about creating something and ourselves being reflected in what we've created. Aristotle knew that in order to do something with excellence, we needed to ask the question why. We needed to be curious. We needed to find out more about what we're trying to solve. And we needed to analyze what we've learned and then come up with the simplest solution possible so as to be the most accurate. When we change how we think about the world around us through asking these questions, we in turn change ourselves, and therefore the products that we create are changed. And the users that use these products will then see a reflection of what we've become in the products that we've created. They'll see the mark of a master craftsman. Finally, Aristotle said, all crafter's skill has to do with bringing something into being, with devising and seeing how something can be made to either exist or not exist, and for which the starting point of production resides in the maker, not the thing made. Thanks.